Hi, this lesson is about factoring trinomials of the form ax squared plus bx plus c, where a, or the leading coefficient, is not equal to 1. So we're going to use two methods to factor these types of trinomials. The first one is called trial and error, and the second one is called the AC method. You don't have to know how to use both methods, but you do need to be comfortable with at least one of them, and then you can choose whatever method you prefer. So I'm going to start with the trial and error method. Trial and error basically means like a guess, but it's an educated guess, and then checking to see if you're on the right track. So with trial and error, you need to remember that when you are factoring a trinomial of this form, that you are doing the opposite of foiling. So you're going backwards. You want to express your trinomial as a product of two binomials. And your product you'll be using integers and variables where appropriate. So in order to get 2x squared in this first position of your trinomial, that means that you're going to need a 2x and an x in the first position of your binomials. Then you need to look at your last term. Your last term is 5. You get that last term by multiplying the last the numbers in the position that we call last with FOIL. So your options are 1 and 5 or 5 and 1. So I put a 1 here and a 5 here. Now, the way you know if this worked is that your middle term or your outer and inner have to combine to give you 11. So how do you get your outer and inner? It's 2x times 5, which is 10, and 1 times x, which is 1x. So 10x and 1x is 11. If you had positioned them differently, like this, you would not have gotten the correct answer. Although it's the same numbers, they're just in the wrong position. Because if you did your outer, that's 2x, and your inner, that's 5x, that would equal 7x. So it would not work out. So that's what it means to do trial and error. Know what numbers you need and then make sure that they're in the right position. Sometimes you have to write it out to see it. All right, here's another one. I have 5y squared minus 18y minus 35. This one's a little bit more complicated. In the first position, there's only one way to get 5y squared. That's with 5y and y, so that's why you see that here. But for 35 or negative 35, you have a few options. You have 1 and negative 35. You have negative 1 and 35. You have 5 and negative 7. And you have negative 5 and positive 7. One of those combinations is going to have to go into your last position. And the way you figure that out is by determining what you need in the middle. So you can try different combinations, but the only one that works is going to be positive 7 and negative 5, positioned exactly the way I showed you. Because my outer is negative 25 y, and my inner is positive 7. So negative 25 plus 7 gives me negative 18. Remember that outer and inner? That's the O and the I in the FOIL method. So that's why I said make sure you're really good at foiling, because that does help when you go to factor and do the opposite operation. All right, so here's another one. I have 4z squared plus 16z minus 9. So again, this one is even more complex than the other ones because I have two options to get 4z squared in the first position. You can use 1 and 4 or 2 and 2. And then for the negative 9, well, that could be 1 and negative 9 or negative 1 and 9 or negative 3 and 3. So we need to see what combination will give me an outer and inner, a combination of 16 in the middle. All right, so you might have to play around with all these different combinations, but the one that works is the one that you see here in the box. The 2z and the 2z, well, that'll definitely give me the 4z squared, and the 9 and the negative 1 in the second position will give me the negative 9. But here I have negative 2z and 18z. So 18z minus 2z gives me the 16z in the middle. So the more you practice these, the better you get at this. So here's another one that I showed you a little bit more of the work on the side. So I have 6a squared minus 17a plus 5. All right, so remember, in the first position, which is what you see here, you're either going to use a 1 and 6 or 3 and 2. And in the last position, you're going to need 1 and 5, and they definitely will both be negative. And the reason I know that is because this is a positive product, so signs have to be either two positives or two negatives, but the only way to get a negative sum, just this, it means that they both have to be negative. All right, so I know it's going to be something either -1 or -5 somewhere. So if you look at what I did here, the 3 and the -5 will give me a -15, and the 2 and the -1 will give me -2. Well, -15 and -2 is definitely -17. So that's exactly the way you have to position them. The 3a and the -5 have to be your outer, and the -1 and the positive 2a have to be your inner. Outer and inner combined to give you the middle term. So you have 3a minus 1 times 2a minus 5. And the best way to check these is to FOIL it out, and it should always equal what you started with. All right, so we're going to do other problems, but using a different method. So again, pay attention to this method. You might like this better, although it's a little bit longer. So we're going to factor by something called the AC method. AC refers to the coefficient of x squared and the constant. And AC means that you are multiplying those two together. So put a little time symbol there. Okay, so we know that ax squared plus bx plus c represents a quadratic expression or a second degree polynomial. The AC method means that the leading coefficient and the constant are multiplied, and then we will be factoring by grouping in order to get our answers. All right, so here I have 2x squared plus 5x plus 3. So again, these could also be done with trial and error if you understood that method. AC means that I'm going to take the leading coefficient and the constant, and I'm going to multiply it, which is what you see here. Then you need to come up with two numbers that multiply together to give you 6, but when you add them, you get 5, and that's the middle term. So what works? 2 and 3. 2 times 3 is 6. 2 plus 3 gives me 5. Then you take that 2 and that 3, and you break down the 5x into 2x and 3x on the next line. So the first term stays the same. 5x gets written as 2x plus 3x, and the last term stays the same. Then you have to go back to the method that we learned in the previous section, which is called factoring by grouping. So right here, I have 4 terms. Collectively, they do not have anything in common, but in pairs they do. So the GCF of 2x squared and 2x is 2x, leaving you with x plus 1. And the GCF of 3x plus 3 is 3, leaving you with x plus 1. Now I have a common factor of x plus 1 that goes first, and you're left with 2x plus 3. So the answer, the binomials in the box, are your factors for the original polynomial. All right, so let's try this again to help you get the hang of this. AC method means I take the 5 and the 6 and I multiply them. That gives me 30. Then I'm looking for two numbers that multiply together to give me 30, but give me a sum of -13. Again, the only way that could happen is if they are both negative. Can't add two positive numbers and get a negative result. So what works is -10 and -3, which you see right here. Now I take that -10 and that -3 and I rewrite -13 in terms of -10a, -3a. The first term and the last term stay the same. Then Again, collectively, all four terms on this line have nothing in common, but in pairs they do. So we factor by grouping. Here, the common factor is 5a, leaving me with a minus 2. Here, the common factor is minus 3, leaving me with a minus 2. Notice that if you have a minus out here, you have to change the sign from positive to negative here. All right, so that leaves me with a common binomial of a minus 2. That gets factored out. That goes first. And then you write what's left, which is 5a minus 3. So again, FOIL it out. Make sure you get the same answer that we started with, and we do. So it works. All right, so here we have 6k squared plus k minus 7. AC is 6 and negative 7. So we get negative 42. Then we're looking for two numbers that multiply together to give you negative 42, but when you add them, you get a 1. That's the coefficient of k. So what will work? 7 and negative 6. We need two different signs in order to get a different product, and different signs mean that you are subtracting, and we get 1. So now we take the k and we write it as 7k minus 6k. Which leaves me with 6k squared plus 7k minus 6k minus 7. By the way, the order of these two doesn't matter. I could have written minus 6k plus 7k and still end with the same answer. So once you figure out what these two numbers are over here, don't worry about which one goes first or which one goes second. It will work out either way. All right, so I take out the GCF of the first two terms, and that's just k, leaving me with 6k plus 7. Take out the GCF here. Well, nothing really stands out as in common, so they always have 1 in common, so you put minus 1. Make sure this sign will always match here. And if I put a minus there, that means this sign changes to plus. All right, so then I get 6k plus 7 as well. So now 6k plus 7 is the common factor, leaving me with 6k plus 7 times k minus 1. All right, here's one more, AC method. I take the 4, I take the negative 15, that gives me negative 60. Then I need to find two numbers that multiply together to give me negative 60, but when I add them, I get negative 17. So there's lots of options for negative 60, but the one that works is negative 20 times 3, because negative 20 times 3 plus 3 is negative 17. Now we rewrite the negative 17 as negative 20x plus 3x. First term and last term stay the same. Factor by grouping. These two have a 4x in common, leaving me with 4x times x minus 5. These two have a 3 in common, leaving me with 3 times x minus 5. The common factor is x minus 5, and the leftover terms are 4x and positive 3. So your final answer is here in the box. Again, check these by foiling until you get really comfortable with this technique. So that's it for this lesson. Give it a try. The more you practice, the better you get at this.